Good morning class. Today topic is properties of determinants. Properties of determinants is an important topic. In this topic, in board exam come in the 4 marks question. In 100%, this topic 4 mark question 100% come in the board exam. A very important topic of this means these determinant of the property is very useful properties. These properties to find the value of the determinants is very useful to make easier in calculation and correct value of the determinants. Some properties are in these determinants like all zero properties, proportionality properties, switching properties, scalar multiplication properties, sum properties, factor properties. Many properties, but I will explain one by one. The first property is here: if the row and columns of the determinants are interchanged, then the value of the determinant does not change. Switching properties. If the row and columns of the determinants are interchanged, then the value of the determinants does not change. How is it possible now? If determinant first, the value of determinant first here a1, a2, a3, b1, b2, b3, c1, c2 and c3. Some value after solving the determinants, suppose some value come here k. After solving this determinant, suppose value of the determinant is k. For example, after interchanging, now after interchange, then after entering the value, determinant is del 2. Now change it. First row convert into first column a1, a2, a3. Second row b1, b2 and b3. Third row c1, c2 and c3. All elements of the determinant first, I am changing the determinant second, but result will become here same k. Means after solving this determinant, the value will come here k, same value of this. I will take example, numerical example here. One second example. Suppose determinant first here 2, 4, 1, 5. What value of the determinant here? 2 into 5 minus 1 into 4. 5 to the 10, 4 into 4. Result is come here 6. After change, the determinant क्या हो जाएगा? After change row and column. Second row, first row convert first column 2 into 4. Second row convert second column 1, 5. Then finding the value 2 into 5 minus 1 into 4. 5 to the 10 minus 4 equal to 6. The value of determinant 6, a value of determinant 6. Any determinant, suppose order 2 and 3, this is not matter. Any order determinant is we can solve here. After interchanging, the value will be both same here. Means first property say when every row converting every column or every column converting to every row, but then value of determinant will be not changed. It is clear. Next property. Second property, interchanging property here. The name of this property is the interchanging row and column. If any row and column, any two rows or any two columns, anyone, two rows or two columns of a determinants are interchanged, then sign of the determinant is changed. Means suppose I have one determinant I am changing only two row, not whole determinant, not all row or column, only two row or two column interchange, then the value of the determinant is same, but sign will be changed. Now I am taking example here. First determinant del 1 here, A1, A2, A3, B1, B2 and B3, C1, C2 and C3. Suppose after solving this determinant values come with K. After solving this determinant come with unique values K. After interchange R1 interchange suppose R3 R2, this is not matter, then determinant will become here del 2 A1 R1 interchange R3, then R3 as C1, this I will write as C1 C2 C3 B1 B2 and B3 A1 A2 and A3. Now look here, this row converted into R3 or R3 converted into R1, means row R1 R3 are interchange, this is symbol of the interchange, then value will become here minus K, means K will be same but result negative. This is very easier to find the value of the after interchanging the value of determinant. Now take the one numerical example. Suppose determinant del 1 equal to 2513. I am taking the determinant of this. Now finding the value of 2 into 3 minus 1 into 5. 2 3 is 6, 5 into 5 will come here 1. The value of determinant is 1. And after R1 interchange R2. Here only two order determinant, then here only two order determinant, then R1 interchange R2. Suppose three order, then R1 R3 interchange, no problem. So then del 2 here come 1 3 will be coming first row and R2 5 coming in the 2 5 coming in the second row. Now finding the value of 1 into 5 minus 3 into 2. 5 into 5 minus 3 into 6, result is minus 1. So now look here, sign change. Value of this determinant plus 1, this is the minus 1, means value of opposite sign of this both determinant. Same here, positive and here negative. Suppose here negative, then here positive. Opposite sign come in the, if we interchange two row and two columns, anyone change. If you change two columns, then same result come here. If you change two rows, then same result come here. Or determinants 2 order, 3 order, this is not matter, but every determinants come in this form result. Next. Yes, now coming the third property of the determinants. This name of this property second zero property. Name of this property also zero property. If any two rows or any two columns, any two rows or any two columns of a determinant are identical, the value of determinant is 0. Means suppose any determinant having two row is identical, means element of two row is same, then value of this determinant will be 0. Second condition, if any determinant having two columns is same, then value of determinant will be 0. Now come an example here. Suppose this is a del 1 here, A1, A2 and A3. Here B1, B2 and B3. Again I am writing A1, A2 and A3. So then means R1 here, A1, A2, A3, same R3 here, A1, A2, A3. That means I will directly write here the value of this determinant is 0. This is not matter R1, R2 या R2, R3. Any two row here same, then result Similarly here, suppose two columns are identical, A1, A2, A3, B1, B2 and B3. Similarly A1, A2, A3. Then result also known. These are identical row form or column. This is not matter, but any two row, any two column here come, then result will become 0. Next property. Yes, now coming the fourth property of the determinants. What is the fourth property here? If each element of a row or column, if each element of any determinant multiplied by any scalar number k, then the value of the determinant is multiplied by scalar number times those number is scalar number k or st, which are number, then k times will be changed. So now I will give the example in this property here. Suppose this is a del 1. I am taking the A1 here, A2 and A3, B1, B2 and B3, C1, C2 and C3. Suppose value of this determinant is come P. Suppose after solving this determinant, value of the after solving this determinant, unique value come here P. Then after multiplying by scalar number k, this scalar number, then determinant will become here del 2. Then here come which row here? After multiplying by k in R1, R2, R3, this is not matter. C1, C2, C3, this is not matter. Any row, any column multiplied, then not matter this. In R1, then result will become here K A1, K A2 and K A3, B1, B2, B3, C1, C2 and C3. Now look here. Matrix will, the whole matrix will be multiplied, but this is not implemented in the determinant. Determinant the particular row and particular row column is multiplied. So I am writing here after multiplying by k in R1. Only multiplied only R1, not R2 and R3, not any other. So when multiplied after multiply k R1 here, k multiplied here, then the value of this, value of the p is same here, but k times here. What result of this determinant? K times of the determinant of the del 1. Now you can say here k times of del 1. P is the value of the del 1. P is the value of the del 1. Value of this p same means del 1. The k times of the del value of the del 2, k times of the del 1. So this result will become value of the del 2 will be determinant of the 2, k times of the determinant of first. Second things here, one more example I will take here. Suppose determinant del 1 here 1, 5 and 3, 4. What value of this? 1 into 4 minus 3 into 5. The result here comes 4 into 4, 3, 5 to 15. The answer come here minus 11. Value of this del 1 is 11. Means the p place here I am writing this minus 11. So, clear it not? Second, after multiplying by k means any number I am taking 2 in R1, then del 2 equal to determinants 2, 5 to the 10, 3 and 4. That multiply R1 multiply, then 2 1 by 2, 5 to the 10. So what result come here? 2 into 4 minus 10 into 3. The result will become here 10 to the 4 to the 8 minus 10 to the 30. The 10 to the 30. 4 to the 8 and 10 to the 30 means 22. Minus 22. And here result come here minus 11. And here come how many times here? 2. So 2 into, we can write here 22, 2 into minus 11. 11 to the 22 means we can say here 2 times of del 1. This is the value of del 2. So 2 times of del 1. Del 1 value of the minus 11. So minus 11, 22 converted into 11 to 22. Minus sign inside the bracket. Then the value of minus 1 is del 1. I am converting the del 1. So in this type, if you multiply it by any scalar number, any row and column, the value of the determinant is k time is changed. K time means those are scalar number you multiply. This number time will be multiplied. Next. Yes, next property, very important property. In these properties, 1 mark question come in the board exam. Mostly in this property base come in the 1 mark question. A current board exam asking in this property, every year asking in the basis in this property, asking 1 mark question every year. What is this property? If A is a matrix, if A is an n into n order matrix, then value of this and this. Suppose A is not determinant here. Here A is the matrix. Right here I am writing this square matrix A1, A2, A3, B1, B2 and B3, C1, C2 and C3. This is the square matrix. This is not determinant. First, what value of this determinant form of this matrix? First, then we convert here by determinant and then finding the value. Then this is a very long answer, long process for finding the answer. Very shortcut tricks for this question, finding the value of this tricks at like this property. Means suppose we multiply k times this. I am multiplying by k times here. Then k times also here multiply, then k a1, k a2 and k a3. Similarly k b1, k b2 and k b3, k c1, k c2 and k c3. This is the matrix, this is not determinant. Applying multiplication rules according to matrix means k will be multiplied by whole matrix here, not single row, single column. Single row, single column is only the determinant. So applying here matrix rules, multiply here, then what result of this we can directly find this according to this property means the what result here k a matrix, determinant of this result will be k exponent n. What is n? Order of this. This is the order of 3 into 3. This is the order of 3 into 3. The k determinant of A. Then find the single determinant value of this. Or what order here? Suppose according to this question, I will write here k exponent 3. Here n equal to 3. In this question, n equal to 3. Then I am putting here and value of the determinant. This is the value of this and this. So very easily shortcut tricks for finding the value of this matrix in determinant form using these properties. Using this property, very useful property in finding the value of determinant form. Next. Yes, next property here, this property. This is the important property. Most is the confusion in this property and how to solve in this question based on this property very confused, but don't confuse. This property say if sum of all elements of a row or a column of a determinant are expressed as sum of 2 or more terms, then the determinant can be expressed by two or more determinants. Simple things, but only one row, one column. Don't two row or don't use two columns. Suppose in two rows, this sum, don't use this property. Suppose in two columns sum, then don't use this property, only one row and one column. And now here, suppose example, this is the determinant here, write a plus lambda, a1 plus lambda, a2 plus lambda 1, a2 plus lambda 2 and a3 plus lambda 3. Next b1, b2 and b3 and c1, c2 and c3. Then now look here, this determinant here having the two terms. Suppose three terms, a1 plus lambda 1 plus delta 1 also, a2 plus lambda 2 plus delta 2 also, a3 plus lambda 3 plus delta 3 also. In 2 and more, 3, 4 term no matter this. Suppose to convert into two determinant. Suppose 3 terms here to convert in 3 determinants. Suppose 4 terms here, then convert in 4 determinants. But suppose in 2 row write in this form, suppose a1 plus lambda 1 or b1 plus lambda 1, then don't convert this. Only single row or single column having in this form, then converting. How to convert here now? Look here. First I will write a1, a2 and a3. First element I in first way, b1, b2 and b3, c1, c2 and c3. Here plus sign, then you write plus. Suppose you have minus sign, then you write minus. Sign depend on the, suppose you have addition form, then write addition sign. Suppose you have negative sign, then write a negative. This is not matter. Next, lambda 1 here, lambda 2 and lambda 3. b1, b2 and b3, c1, c2 and c3. Look very carefully here. First element in first and second element in second. Suppose you have third element, then plus and minus, then write here next determinant. But only one row or one column in this form determinant, then you can change in 1, 2, 3 form of the determinants. This is then solve this determinant and then solve the determinant and both adding get answer. It is clear? Means any same question in column form. Suppose here a1 lambda 1, b1 lambda 2, c1 lambda 3. Then according to column you can change. This will not matter. Is there, suppose lambda 1, lambda 2 in this column form, but then again also write here a1, b1, c1, a2, b2, c2, a2. Here lambda 1, lambda 2, lambda 3. This lambda 2, lambda 3 convert here lambda 1, lambda 2 and lambda 3. The column and row, this will not matter. Very easily you convert and solve. But don't confuse in this type question. Next. Yes, now coming in the last property of the determinant, property number 7. Properties 7 and 6 something similar, but something confusion in this property and properties 7 and 6. Minor difference in these properties. What properties of this? If each element of any row or column of a determinants added k times the corresponding elements of the another row and column, then the value of determinants remain unchanged. Means property 6 and 7 something similar but minor difference. Don't confuse in this property. Now look here. Suppose example here, and this is the value of the determinant. Suppose determinant a1, a2, a3, b1, b2 and b3, c1, c2 and c3. This is the Euler form of the determinant. Suppose question come in this form, del 1. This determinant adding the k times. Suppose a1 plus k times of c1, k times of b1, this is not matter. Suppose you write a1 plus k times of c1. Suppose this question converted in this question form, a1 plus k times of c1, yeah, a1 plus k times of b1, this is not matter. Again a2 plus k times of c2 and a3 plus k times of c3. So b1, b2 and b3, c1, c2 and c3. First of all, I will check this here. This property c1, c1, c2, c2, c3, c3. Most students doing this result is 0. This is wrong. Some students converting this and this form and finding the value of this. Yes, now okay. First separating this, then finding the value. What value? Value of this determinant. First I will use separating form. Separate this a1, a2 and a3 first element. Second b1, b2 and b3 all elements remain same here. c1, c2 and c3 and plus. You have plus sign, then you write plus. Suppose you have minus sign, then you write minus. Then I will write again here k c1, k c2 and k c3. Again b1, b2 and b3, c1, c2 and c3. Means अब look this determinant a1, a2, a3, b1, b2, b3, c1, c2, c3. Same determinant this. The what value of the determinant is del. This is the del 1 and value of the determinant is come del. This and this determinant is the same. What value of the determinant is del. I am putting a del plus sign. What value are taking common here? I will change it again. Del 1 equal to del. Value of the determinant here del. I am writing a del plus sign, then putting a plus sign. Now taking common k, or what left here, c1, c2, c3, b1, b2 and b3 and c1, c2 and c3. Then we'll put here del k, c1, c1, c2, c2, c3, c3. So means r1 and r3 both identical. R1 and R2 are identical, means k into 0, the result will become here k. The del 1 value has come is the what the result of this determinant is del. Original means what value of this determinant of this determinant, the then same value of this determinant is called k. And here we write here R1 and R2 are identical. Means दोनों identical है, the result will be 0 here. I am putting here 0 because R1 and R3 are identical. Then putting here 0 into k 0, the result will come here this. So this is your final result. Means don't confuse in this type question. Suppose k type, don't put directly 0 here. The value of this in this type determinant is value of the original determinants. Then not only